Okay, so in the 11th chapter, we're going to talk about method for eliciting probabilities. What do you mean by eliciting? So it means how do I know the exact probability in your mind? Okay, because we talk about those kind of probability tree, decision tree. Those tree all requires to know what's the probability of a specific event to be happening, right? But we never talk about how those probability was given in the first place. But in reality, as a decision maker, he or she may know the probability in their heart, but if you are giving advice to this person, you might need to use some method to help this person to assess that probability. Okay, so first of all, so one way to do this is use a verbal expression of probability. Either in English, in Chinese, or in your language, you should be noticing that there are lots of words that are related to probability. Like in English, some words like unlikely, probable, expected, they were all sort of related to probability, right? And I don't know about you guys, but when I was learning English in like junior high, my English teacher would list a list of words like often, likely, and something like that, and she ranked the order and saying that in English that's the sort of general definition of the likelihood of these words. But it's actually obviously not like clearly defined. For example, what's the associated probability with unlikely, do you think? Yeah. Less than 50. Okay, so you have a wide range. You basically say 0 to 50 or maybe 1% to 50 are all unlikely. I will say, in my mind, it would be around 30%. Okay, and someone else may think 20% is unlikely. So this is too unstable. Also, although there is sort of a rule of thumb in English and maybe in your own language as well, but if you ask this kind of people to assess the probability in the lab, not just the number they gave are not stable. It is the ranking itself is not stable. So some people might think unlikely is more likely than probable. Some people think the other way around. Okay, so it's very unstable. That's why verbal expression is probably a bad way of eliciting probability. Okay. Also, this kind of if you ask people to assess the same word, say unlikely, okay, or same expression. For example, like if you travel abroad now, okay, if you travel abroad now and caught an illness, and if I ask you what's the probability that this person or you is having an influenza or is having a COVID-19, then people will generally think it's more likely to be COVID-19. Even I use the same word probable. Okay, I'm saying you probably get COVID-19 or you probably get influenza. The same word probably, people will associate it with a much higher probability with COVID-19 because nowadays COVID-19 is a thing now. Okay, so it's influenced by context. That's what it means. Okay. Also, the same expression is often interpreted differently for a negative and a positive event. So basically, in plain English, that means I'm less likely to be unfortunate, but more likely to be fortunate. Okay. So if I'm talking about, you heard a word, you are going to probably get sick next week. You will associate probably with a lower probability than average, than what you usually think as probability. But if I say you are probably gonna get really rich in the future, you're gonna associate it with a much higher probability than getting sick. Because you want the good thing to happen, but bad thing not to happen. So it really depends on like different events. Okay, so that's again why verbal expression is not really a good way. It's too vague. So obviously you want to have a probability. Okay. Wait. Okay, the order of the slide is actually messed up somehow. I don't know why. I will adjust that and upload a new version later. Okay, but now first look at this one. So the way not verbally but numerically to assess probability. For one way, this way is called direct assessment. What is direct? The most direct way is I just ask you. Okay. So what is the probability that the product will achieve break-even sales next month? Posing the direct question. And you will give them a marking point on the 0 to 1 scale. But obviously we've learned this already for many, many times that asking is, not very accurate in many, many different ways. Okay. And one way to sort of help this is, I already say this in the previous class, that people are good at frequency or odds, at least better than probability. So if you ask them the odds, like 1 out of how many times do you think this event is going to happen, he will say like 1 in 1,000 odds. Then you can translate that into 1,001 over 1, something like that. Okay, so that's a better way of direct assessment. Okay, and there is also an indirect way of assess the probability. So this one is using something called the probability wheel. So this wheel, for example, here, this is around 28%, I will say. This is 72%. And you will ask this person, for example, if it is in the red zone, okay, wait, let me think. Okay, so you ask this person so you're asking the probability of the event A, right? Probability of the event A. So you ask this person, but choosing between two options. Option A, so option A is if event A happens, you get 10,000 US dollar. If event A does not happen, you get 0. And this is option A. Option B is if this pointer, so this is a random pointer, it will point randomly at this wheel. Okay. If this pointer is red, is pointed to, if red, okay, red means the pointer point to a red zone. You also get $10,000. If it is blue, you get 0. Okay, so between option A and option B, you choose one. You ask the decision maker to choose one. If the decision maker choose A, what does it mean? It means that he thinks option A is more likely to happen than 28%, right? Right? Do you understand what I'm saying? These are the same question, except that event A and red and blue are inverse. So event A not happen means not event A. Right? So event A and not event A together has a probability of 1. Red and blue also together has a probability of 1. Okay, and here in option B, you have a 28% chance winning. 28% chance winning 10,000. Here, you have a probability A chance winning 10,000. The reason why you choose option A must be PA is greater than 28%, right? Is it clear? Okay. If the person you're helping or yourself want to choose option A, then you will decrease the zone of this red zone. You will decrease it to 27%. Make a new question. Now this new question, so you draw a new wheel, okay? This new wheel, here there is only 27%. And you ask the same question again. So this time this person is comparing between probability A and 27% basically. If this person still choose option A, then you further decrease the probability. And if the person choose probability B, you increase. So if you choose probability B, wait. Oh, sorry, I got it reverse. Sorry. Because if you choose probability A, if you choose option A, it means option B is not attractive enough. So you actually have to increase, not decrease. So this should be 29%, sorry. So you increase it to 29% and ask the question again. This time the option B is more attractive, right?
But what's event A?
Any event. That's the question we are referring to right now. Any event A. Yeah, the question the probability that you want to know.
But we don't know it.
You know it. I'm just giving an abstract example. Yeah. So 29%. You ask the question again. If this person still choose option A, it means 29% is not enough. You further increase 29%. Okay? And if this person choose option B, that means option B is too attractive. Then you decrease the attractiveness of probability, this wheel, option B. So you decrease the probability to 27%. You do this until this person tell you he's indifferent between two options. In that case, you will, and in that case, the red zone's probability will be PA. Understood? So for example, if 28% this person say I want option B, and 29% this person say I want option 28% this person say I want option A, and 29% when you increase it to 29%, this person say that I want option B. That means he think PA is between 29% and 28%. You can further do it with a slightly slice, right? You now move it to 28.9%, right? So you can do it as long as you want. Okay, so you can get a very precise number of probability that this person say that he is indifferent between two. Or here, if you only care about the probability in terms of precision, you only care the precision to to the 1% level, then this is good enough. You say that this person, think PA is 28.5, then it's good enough. This is actually very similar to the risk preference experiment we ran. The risk preference experiment we ran last time, the table I gave you in the beginning of the last class. Is that last class? Yeah, something like that. So we have like 10 questions. I say that you should only have one switch, right? And most people switch at question 4. that means people are sort of indifferent between question 4 and question 5. That's why you switch at question 4. Or actually, you switch at question 5 means you are indifferent between question 5 and question 4. This one and the previous one, you are sort of indifferent between your indifferent point is in between that. That's how we pin down your risk preference in that game. Here, this is how you pin down a specific probability. And this is indirect because I'm asking you a bunch of binary questions. I'm not asking you a number directly. Okay? Okay. And another assessment we were talking about assessment of a single probability. So either PA or not PA, right? So it's just one event happening or not. Another case where assessment of a probability distribution. Okay. The best practice is the following. So you first decide and revise a possible range. What it means by decide and revise? It means that you ask this person, what do you think is the I will come back to this next week. Okay, so this is end of the class. Okay, if you have any question, you can come to me. And by the way, today is April 21st. I need you to at least tell me the group that you belong to by the end of this month. That means at least next class you should be able to tell me. Okay.